So this video, we're going to monitor the rate of reaction by measuring the change in pressure of a reaction system. Like we have mentioned last times, okay, we can measure different kinds of physical property to monitor the rate of reaction. So this video, we're going to talk about change in pressure. So when can we monitor the rate of reactions, okay, by measuring the change in pressure? So basically, you need to have a change in number of moles of gases. Okay, remember we're talking about gas. Okay, so the number of moles before and after have to be different. That means in the process they may have more gas produced or some of the gas have been consumed. Okay, so by doing this, okay, there will be a change in pressure of the reaction system. But also, okay, you have to remember the gas produced are better to be insoluble gas, okay? Because if it's soluble gas, it will dissolve into solutions, then it will have a smaller change in pressure of the reaction system again. So that will be insignificant to measure the pressure change in this process, okay? So basically, I'll just show you some example here. So we don't have gas here, so this one will be 0. We have gas here, so therefore from 0 to 1. So this one can be used because it is a insoluble gas. Okay, so H2O2, okay, become this one should be 0 because we don't have gas. This one we have 1, okay, because we have gas right here. Oxygen are slightly soluble, so I think this one still be okay, okay, to use this setup. And then on the left, no, okay, on the right, okay, we have 1, okay, but this one, okay, not preferred because SO2 is quite soluble in water, so therefore the changes in the pressures may not be that significant, okay. So this one, okay, we have gas and gas and gas. On the left hand side we have 2 here, but on the right hand side we have 1, okay. So therefore in this system, okay, we can also still using this one, okay, to monitor rate of reactions, okay. And then on the left hand side, okay, we have no, okay, right hand side we have 1, okay, but CO2 is slightly soluble in water, is quite soluble in water, so therefore this one are not quite preferred, okay. So again, okay, mainly is for nitrogen, hydrogen, okay, this will be more preferable. Oxygen is more preferable, okay. So it will be like that. Just give you one more example. If we have like nitrogen, oxygen to form nitrogen monoxide. In this case, we have 2 on the left, okay, and then 2 on the right. Then in this case, you will find that the pressure system should have nothing changed. So in this case, okay, we are not using that. So the setup, okay, will be like this, okay. Basically, you have a conical flask, you put the acid in it, you put a magnesium ribbon in it. So you see that the whole thing, okay, will be in a closed system. Again, because initial rate is so fast, we don't want to have any gas, okay, leaking out from the system. So basically, we will have a design, okay, like this way. So if we just maybe turn the flask, okay, side by side, you shake it, okay, allow the hydrochloric acid to this beaker in it, okay, to fall down, okay, so the acid can be coming out to react with the magnesium ribbon. So the gas produced will create a higher pressure. So we have a pressure sensor here connected with a data logger. So the pressure changes can be detected by this sensor, and the data can be collected by the data logger, okay, and then we can input to the computer and we can plot a graph immediately. The graph, it should be the time and the pressure. Remember, this time, okay, it is not a product time graph, okay. The pressure at the very, very beginning, okay, in this system without any hydrogen produced, it should not be 0 because this pressure in the pressure inside this conical flask should be atmospheric pressure. If the unit that I'm using is ATM, then remember this one very important. It is not starting from 0, it is starting from 1. Okay, because that will be the atmospheric pressure. This is something that you have to remember. Atmospheric pressure. Okay, it was starting from 1, so therefore the shape, okay, should be more or less like this way. Okay, it's not heading, it's not heating origins, okay, at the beginning. Okay, one thing very important, you have to pay attention to that. So advantage of using data logger are very important because it can collect data over a very short time interval. For us, maybe like for human beings, maybe every 2 seconds, take one data, it will be quite good already. But for them, okay, it may be like 0.1 1 second, okay, or 1 second at a time. So you can find that, okay, they can take data, okay, within the whole progress more often than us. Okay, so with more data, the result will be more accurate. Not only this, okay, the data can be presented in the form of graph immediately because it connected to the computer. These are the advantage of using data logger. Okay. So this is the procedures, okay? So first of all, you have to run the data logger software in the computer, tilt the bottle so that the HCl can come out, okay, and react with the magnesium ribbon, and immediately start recording the pressure inside, okay, and the magnesium until when, okay, until the magnesium has complete. You can scan the QR code here to check, okay, how the experiments to go. So examples, again, okay, we have a table given to you and ask you to plot a graph. So first things, okay, identify when the reaction stop. So you can see 126.9, okay. So this will be the point that reaction stop. So if we need to calculate the average rate, will be 126.9 minus 101.4, okay, over 36 over minus 1. So the unit is kPa in this case, okay. So write the chemical reactions, okay. We have sulfuric acid together with magnesium. So basically the equation is easy, okay, magnesium, sulfuric acid, and then salt and hydrogen. So plot a graph. The y-axis is the pressure, the x-axis is time, okay. So you see that this one, okay, they try to cut it short, okay, because it's not the ATM that I've mentioned just now. If ATM I mentioned just now, this one is 1, it will be okay to be 2, to be 3, to be 4, like this, okay. That one will start from 0, but this one, okay, is starting from 0. The atmospheric pressure is 100, and the changes is just like 20 something. If I say 200, 300, 400, like this way, then the graph will be very narrow like this one, okay. So this is not something that we want, okay. So therefore we want to expand the scale right here, okay, from 100 all the way, I think up to 130 will be good enough. So if you want to expand this one, 100, 110, 120, 130, then you can see the distance, okay, between this is only 10. But if you mention this one, okay, will be 100, then you may need to have this lightning bolt symbols, okay, these lightning bolt symbols. It can help you to cut short the scales, okay. So this one is something that I want to remind you. At what time the reaction complete, okay, mentioned already, 36 seconds, okay. And why was the pressure inside not equal to 0? Just as we mentioned, this one is very important, okay. So put a star for question number D, okay. So D, because there was air inside the flask, okay, initial pressure should be actually the atmospheric pressure. Okay, so very important for this. Calculate the average rate. Okay, that will be kPa per second. Easy, not going to talk about that. State 2 advantage of using data logger. We mentioned this as well. So this example, please highlight D and F. Okay, very important. So one more examples. So student investigate the reactions between the sodium and ethanol. Okay, so in this chapter, actually you can see many different kind of reactions. Okay, so this reaction you haven't learned before, but no worry. Okay, you just have to focus any special product is formed, okay, which method you're going to monitor the rate of reaction. So in this case, we have gas formed in the product, okay, and on the left hand side 0, this one is 1, so therefore in the process, okay, we can use measuring the change in pressure to monitor the rate of reactions. So this one, okay, connected to data logger interface, so this have to be the pressure sensor. Okay, pay attention to spelling is ending with OR. Okay, so sketch a graph. Sketch, that means you don't need to have scale. So randomly, okay, to put up something like this. Okay, you can say pressure. Okay, this time you can use ATM or you can use kPa, up to you. Okay, and the time, okay, we're using minutes, okay, or second. Okay, is also up to you. This one have to be minute. This one have to kPa. Okay, so you have to read the question carefully. So this one, okay, like this. Remember, start from not 0. It is 1, okay, it will be something like this, okay. This point is very important when you polygraph pressure against time. So second one, okay, you see that I put a star here, okay. So students try to investigate the rate of reactions, okay, of this one. So this one should be 0, this one should be 1, okay. But again, SO2 is quite soluble, okay. So is it appropriate weights to use or measure the volume or pressure changes generated? A volume and also pressure. That means using gas range or using the pressure sensor. The answer is no. Okay, you can have a look of the have a look of the answer. It's very soluble in water. So volume of SO2 measure is too small. Some of them they get back to the solution, so therefore the one that we collect is very small, or the change in pressure is not obvious, or you can use the word insignificant. Okay, so because it's insignificant or it's not obvious, so therefore we seldom use measuring the volume or change in pressures, okay, when we're dealing with SO2. Okay, that's all for this video. Basically, you have to know that when we can measure the change in pressure to monitor the rate of reaction when there's change in number of moles. So for example, in this case, okay, we have 0 here, 0 in the reactants, okay, and we have 1 in the product, and N2 is insoluble gas, so we can use this method to help. Okay, if we have like N2 plus O2 become NO, so you have 2 on the left hand side, 2 on the right hand side, 2 to 2, okay, it will be no changes in number of mole gases. So in this case, okay, we are not using this method. Okay, so advantage of using data logger, okay, remember, collect data over very short time interval, and also the data can be presented in the form of graph immediately. Okay, so the sketches of the setup. So basically you just connect it to a pressure sensor, and then you tell them that this one will connect it to a data logger. That will be good enough already. Okay, you don't need to draw something very special. Okay, so like this. Okay, that's all for this video. Bye bye.